Okay, hi. Good morning, good afternoon, or good evening, wherever you are, wherever time you are at. So, as mentioned, for this week, the labs tutorials will be done online. We'll be recording. So here we are. I think there are about 5 questions here. So we record them in 5 different segments. So you can just watch them one by one. Doesn't have to be one at one go. So as and when you're ready, you can just scroll through the video and just proceed on. So let's go on with the first question. I'm going to share my screen. Okay. So the first question requires us to write the program using recursion such that when we are given input n, we will generate n binary bit strings in increasing order. So it's 0, 0, 0, 1, 1, 0, and 1, 1. If it's n equals to 2, if n equals to 3, it'd be 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 100, 101, or 0, and 111. Okay, so yeah, so that's about it. And the question it asks is to use recursion for this. So remember in recursion we mentioned that we have 3 things to look out for. So number 1, what is the terminating function? So this is typically one of the key things we look at. Number 2, what is the recursion? And number 3, what is the reduction? So based on these 3 things, it will determine how we write our recursive function. So just take a moment to think about this. What can be a possible way that we do this print? Okay. One possible way is that we start first from string length 0, and then we constantly add on to the string. So meaning that initially the string is empty, and then as the string as we move on the recursion, we gradually build up the string. And when the length of the string is equivalent to how long we want the string to be, then we can stop. Okay, that is definitely one way to do it. And let's try to think about it in this manner. So let's say if I have a definition, print binary string. In this case, it's print the bit string. I'll take in a certain parameter. So maybe some parameters. And perhaps one of the condition is if the string has the required number of characters, I print the string. Else, I do something like the version here. So basically, that is what the string should look like. That's all. I mean, that is what the recursive function should look like. So now the only thing is, how do we fill up these 3 conditions? So one of the condition is that I want my string to have n characters, correct? So if n equals to 2, I want it to have 2 characters. One way to do it is that we can pass in the number of characters to be printed, and then gradually we reduce the number of characters to print. So meaning that I pass in my initial call will be 5. and then I gradually remove the characters print. So let me get my input. Maybe something like initially, let's say my print bit string. Let's say initially I pass it. I say I want it to print 5 characters. Every single time I print a character, I probably will want to decrement this. So in my print, in my recursive, I want this to be 4, something else. So if I'm documenting this every single time, what this means is that my terminating condition probably is something like if this value equals to 0, I do something here, which is my terminating condition. Okay. So this definitely is something possibly that we can do. Okay, let's look at this part. If the string has the required number of characters, I print the string. So let's say if the string has a required number of characters, if I suppose I pass in as parameters the number of characters remaining would be printed. So this variable is for n. So I have n, and if n is equals to 0, means there's no more characters that needs to be printed. I print the string. Else, I will have to do some recursion. Okay. So perhaps what I can do is, what is now the string? In my recursive step, I probably have to pass in the string. Means every single time I need to reduce my string by 1. This is the reduction step. There's a reduction that happens here. In this is part of the recursive step, and I'm calling my print bit string. However, I want to tell this print bit string to be printing out something along the way. And what I will tell it to print is that I'll ask it to print out a certain binary string. Recall that the question asks us to print if it's 2, 0, 0, 0, 1, 1, 0, and 1, 1. So it goes to say that we need to print, we need to pass in also a string that is to be printed. So let's say that this is binary string. So if n is equals to 0, it means that my binary string is complete. I'm trying to erase all it. So if n is equals to 0, it means that my binary string is complete. And what I want to do next is to print out the string. So let's assume that I will pass in the binary string here. And I can just print binary string. Else, I have to do some recursion. We have already established earlier, we probably want to do some reduction here. So I would want to do something that looks like this. But I need to do some reduction. So I will need to reduce the number of characters that needs to be printed. I reduce it by 1. And I also want to add in the character that's to be printed. The question states that we should print it in ascending order. And so I'm going to print it in ascending order with 0 first. Sorry. So let's try to run this function. And let's say I do a test. If I want to print out 2 characters, notice that it passes in 2. It goes into this, which appends 0 to my blank string. Goes into this again, appends 0 and 1 to my 0 string. Goes into this again and realize that it is the length is 0 and it breaks out. Likewise, for the second as well, it first passes in 1, reduces it by 1, goes in. Then for my prefix to be 1, it appends 0 and 1 and goes into the loop again, and it breaks out of the loop. Let's do drawing to show how it looks like. The advantage about this being recorded is that if you think I'm talking too slowly, you can always watch the YouTube video at ×2 speed. So what we have is print bit string to length. What happens is it goes into PBS 1, 0 and PBS 1, 1. This is the first one that goes to, and then PBS 0, 0, 0. Second one, then PBS 0, 0, 1. Then it breaks out the loop because the terminating condition has been reached. Breaks out the loop because the termination condition has been reached. And PBS 0, 1, 0. PBS 0, 1, 1. So this is how the recursion tree would look like. Okay, let's look a little bit deeper into this. If I say I want to have 3 or 4, sorry. Yeah, so this prints out 4. So this question prints out the strings in the ascending order. If let's say we want to print this in the descending order, what we can do is we can change this to 1 and 0, and this should print out in descending order. So initially it was 0 and 1, and this is in descending order. If I want the print out to be in descending order, I just need to change this, and the printout will be in descending order. And I think that's it for this question. Maybe we can do one more thing, which is analyze the complexity of this. Okay, let's see how the complexity works. This is P of n, P of n minus 1, P of n minus 1. It's 1 time, 2 times, 4 times, and 8, 16. So every single time is a character C. This runs for n times. This is a geometric progression. 1 minus r power n, 1 minus r. A is equals to 1. R is equals to n. N is R is equals to 2. This n is equals to n. So this is 1 minus to the power n, 1 minus 2, which is a 2 to the power n big O. So this is a big O to the power n algorithm, which is exponential increasing function. Okay, I think I think that's all for this question I have. I hope this is clear enough, and I'll see you in the next video. Thank you.